Concerns arise when adding new circuits to a family of electrical panels. Overloading of service conductors is a primary concern. Each addition increases the total load on the service conductors. It's crucial to ensure that the conductors are rated for the combined amperage of all connected loads. Failure to do so can result in overheating and fire hazards. Compliance with code is essential. Article 220.3 C1 requires that service conductors be rated for the sum of the maximum loads in the service equipment and all connected load centers. Article 220.31 mandates the use of main overcurrent devices of sufficient amperage to protect the service conductors. Coordination of overcurrent protection is another important factor. Article 240.21 B requires that overcurrent devices be coordinated to ensure that the correct device trips during a fault or overload. Adding additional load centers can disrupt this coordination, potentially leading to electrical hazards. Several assessment and mitigation strategies exist. Firstly, calculate the total load. Determine the maximum demand of the existing loads in the service panel and load centers. Add the estimated load of the new circuits to calculate the total load. Secondly, check the conductor ampacity. Compare the total load to the ampacity of the service conductors. If the conductors are undersized, an upgrade is necessary. Thirdly, install a main overcurrent device. If the total load exceeds the rating of the existing main overcurrent device, install a new device of appropriate amperage to protect the service conductors. Fourthly, coordinate overcurrent protection. Ensure that the overcurrent devices in the service panel, load centers, and new circuits are coordinated according to National Electrical Code requirements. This may involve adjusting breaker trip ratings or replacing devices. Fifthly, consider a service upgrade. If the calculated total load significantly exceeds the capacity of the service conductors, an upgrade of the service equipment may be necessary. Communication with customers is paramount. Educate customers on the potential risks and code violations associated with overloading service conductors. Offer them options such as upgrading the service or limiting the number of new circuits added. Document all discussions and decisions made to provide transparency and protect yourself from liability. Set boundaries by clearly stating that you will not proceed with the installation if the customer is unwilling to adhere to code requirements. Safety should be the primary concern when dealing with situations like these. Thorough assessment, careful planning, and communication with customers are essential to prevent electrical hazards and ensure compliance with the National Electrical Code. To elaborate further on calculating total load, it's important to utilize appropriate load calculation methods as prescribed by the National Electrical Code. These methods take into account demand factors, which are statistical reductions in the expected load based on the type of occupancy and the diversity of loads. For example, a dwelling unit will have different demand factors applied to its general lighting and appliance circuits compared to a commercial building. Accurately determining the maximum demand of existing loads involves inspecting the existing service panel and load centers. Note the amperage of all branch circuit breakers and identify the loads they serve. For continuous loads, which are loads expected to operate for 3 hours or more, the National Electrical Code requires that the branch circuit be rated for 125% of the load. This is crucial for preventing overheating of conductors and breakers. When estimating the load of new circuits, be realistic about the anticipated usage. Consider the types of appliances or equipment that will be connected and their respective power consumption in watts or volt amps. Consult manufacturer's specifications for accurate data. For general-purpose receptacle circuits, it's often acceptable to use a standard load value per receptacle, as specified in the National Electrical Code, unless there's reason to believe that the actual load will be significantly higher. Once you've determined the individual loads, apply the appropriate demand factors and sum them up to arrive at the total calculated load. This is the value you'll use to compare against the ampacity of the service conductors. Regarding checking conductor ampacity, the National Electrical Code provides tables that list the allowable ampacities of various conductor types and sizes based on their insulation rating and installation conditions. These tables take into account the ambient temperature and the number of conductors bundled together, as these factors can affect the conductor's ability to dissipate heat. It's crucial to use the correct ampacity table and apply any necessary correction or adjustment factors to account for these conditions. For example, if the conductors are installed in a hot environment or bundled tightly together, their ampacity may need to be reduced. The size of the service conductors must be adequate to carry the total calculated load without exceeding their allowable ampacity. If the conductors are undersized, they will overheat, leading to insulation damage, reduced conductor life, and potentially fire hazards. In such cases, a service upgrade is necessary, which involves replacing the undersized conductors with larger ones that are properly rated for the load. When installing a main overcurrent device, it's important to select a device with an appropriate interrupting rating. The interrupting rating is the maximum fault current that the device can safely interrupt without failing. The available fault current at the service entrance can be calculated using engineering methods or obtained from the utility company. The interrupting rating of the main overcurrent device must be equal to or greater than the available fault current. The amperage rating of the main overcurrent device should be selected to protect the service conductors from overload. The National Electrical Code specifies rules for rounding up or down the overcurrent device rating based on the conductor ampacity. It's important to follow these rules carefully to ensure proper protection. Coordinating overcurrent protection involves ensuring that the overcurrent devices in the system are selectively coordinated. This means that when a fault or overload occurs, the overcurrent device closest to the fault should trip first, minimizing the extent of the outage. Selective coordination can be achieved by using overcurrent devices with different trip characteristics. For example, a main breaker with a time delay characteristic can be used to allow downstream breakers to trip first under moderate overload conditions. The National Electrical Code provides guidance on selective coordination requirements, particularly for critical systems such as emergency power systems. Coordination studies may be necessary to ensure that the overcurrent devices are properly coordinated. When considering a service upgrade, it's important to evaluate the entire electrical system, including the service entrance conductors, the service panel, and the grounding system. The service panel must have sufficient capacity to accommodate the new circuits being added. If the existing panel is full or undersized, it may need to be replaced with a larger panel. The grounding system must also be adequate to provide a low impedance path for fault current to return to the source. This is essential for clearing faults quickly and safely. A comprehensive service upgrade may involve replacing the service entrance conductors, the service panel, the grounding system, and the meter enclosure. It's important to obtain the necessary permits and inspections to ensure that the upgrade is performed in accordance with the National Electrical Code and local regulations. Educating customers is crucial for ensuring that they understand the importance of electrical safety and code compliance. Explain the potential risks associated with overloading service conductors, such as overheating, fire hazards, and equipment damage. Provide them with clear and concise information about the required upgrades and the associated costs. Answer their questions patiently and address their concerns. Offering options allows customers to make informed decisions about their electrical system. Present them with different scenarios, such as upgrading the service to accommodate the new circuits or limiting the number of new circuits added to avoid overloading. Explain the pros and cons of each option and provide them with estimated costs. Allow them to choose the option that best meets their needs and budget. Documenting discussions is essential for protecting yourself from liability. Keep a record of all conversations with customers, including the date, time, and attendees. Summarize the topics discussed, the options presented, and the decisions made. Obtain the customer's signature and the documentation to acknowledge their understanding and agreement. Setting boundaries is important for ensuring that you are not asked to compromise safety or code compliance. Clearly state that you will not proceed with the installation if the customer is unwilling to adhere to the National Electrical Code requirements. Explain that you are obligated to prioritize safety and that you cannot be responsible for any consequences that may arise from a non-compliant installation. Remember, safety should always be the primary concern when dealing with electrical systems. Thorough assessment, careful planning, and communication with customers are essential for preventing electrical hazards and ensuring compliance with the National Electrical Code.